Okay, so this is going to be the last measure of relative standing, and this is what we call z-scores. And z-scores, basically, we will use them for the majority of this class. So a z-score is simply just the number of standard deviations a data point is above or below the mean. Okay, so this is basically telling you relative to the mean where this data point is. So we require that our data must be normal. So from right off the bat, we need to make sure that our data kind of looks like a bell curve. Okay, if it looks something else, then we can't really talk about z-scores. So if you have data that looks like a skew, something like that, then z-scores are not going to be okay. It's not really useful. Okay, so there's two different formulas. Let me go ahead and tell you what these are. I'll go ahead and write down x. Here, x is what we're going to call my data point. So any data point that I was looking at. Okay, so that's my data point. X bar is what we're going to call my sample mean. And then S is what we're going to call my sample standard deviation. Okay, so when I have these things, okay, my z-score is going to be equal to x minus x bar divided by s. Okay, this is only a z-score for a sample. Okay, now if I knew the entire population, so if you remember, this is the entire population. I don't know what to, I can't sample, I can't get everyone, so I'm going to get a small sample. Okay, so if I, but I did, let's say hypothetically I did know what the population was. Okay, then this is going to be equal to z equals x minus mu divided by sigma. Here, this mu is what we're going to call my population mean. And then this sigma is what we're going to call my population standard deviation. Now, in this class, the one formula that we're mainly going to be looking at is this one. Okay? Now, the one for the sample is still good, and in theory, we will do that. We kind of do that, but there's going to be parts of the class where we're going to mainly talk about the population. Okay? So this is the formula that we're mainly going to use. Okay? Now, some z-scores, as the reason why we talk about z-scores in terms of like how far they are from the mean, well, we can talk about things such as outliers or things that are unusual. Now, things that are unusual, when we talk about z-scores, we say that things, usually, some of the usual values will always be between -2 and 2. Okay, so for right now, if I have a z-score that's between -2 and 2, it's going to be usual. Anything else? Unusual. Okay, I don't know what that's not very likely to occur. Okay, so I want my z-scores all to be between -2 and 2. Okay, and if they pass this guidelines, then it's going to be unusual. Okay, so let's do this problem to better understand z-scores. So a male has a pulse rate of 52 beats per minute. Males have a mean pulse rate of 67.3 beats per minute and a standard deviation of 10.3 beats per minute. So what is the z-score of a male's pulse rate? Okay, so let's start off with that one. So what is the z-score of the male's pulse rate? Okay, so we know that z equals the data point minus the mean divided by the standard deviation, sigma. X in this case is going to be 52 because that's what that male's pulse rate is. So this could be me. My pulse rate is 52 beats per minute. Okay, I'm subtracting the mean because I want to see how far away is it from the mean. And I'm dividing it by the standard deviation because I'm basically trying to see, okay, well, how many, I know that one standard deviation is 10.3 beats per minute. Well, how much is that relative to the difference of the mean? So I'm going to put this into my calculator. So I'm going to have 52 minus 67.3. Okay, the top part is going to give me -15.3 divided by 10.3. This is going to give me, so let's round it to 2 decimal places. Z-scores usually want to be to 2 decimal places. This will be -1.49. This is my z-score. Okay, so that's the answer for the first part. Okay, so now my second part is this unusual? Well, usual values for z-scores are always between -2 to 2. Okay, that's what I'm going to say. Now, in this case, -1.49 is a number that is between here. So is it unusual? Not unusual. Okay, in order for us to say that this is going to be unusual is if it was outside of it. So this is going to be not unusual. Unusual. Okay. All right. So that's what we have. Okay. So this is going to be not unusual. Okay. Now my other one is, what does the z-score mean? Okay. So what does this -1.49 mean? What this means is that a male with a pulse rate, okay, of 52 beats per minute is 1.49 standard deviations below the mean. Below the mean. Okay, that's what basically that means. So a male with a pulse rate of 52 beats per minute is 1.49 standard deviations below the mean. With that, now notice there's a couple things that I said. So what I'm saying is that, first of all, why is it below the mean? Well, that is below the mean because it's negative. And we already knew it was below because 52 is definitely below the average pulse rate of all males. Now what exactly does this 1.49 mean? Well, 1.49 standard deviations, that's almost 1.5 standard deviations. That means if I were to have 52, okay, so if my 52, right, and if I add 1 standard deviation to that, which is if I add 1 standard deviation, 10.3, okay, well, what is that going to give me? Well, that's going to give me 62.3. Now, what this is telling me is that I'm not 1 standard deviation away from the mean. I'm 1.49 standard deviations away from the mean. So I take 10.3 and multiply it by 1.49, and what I should get is the mean. So 52 plus 10.3. Whoops, I'm running low. Okay, so 10.3 times 1.49, okay, is going to give me approximately 67.3, okay? So I'm approximately going to get something like that, okay? So that's all it just means, that if my pulse rate of 52 beats per minute, right, this is just telling me how far below am I from the mean, and I'm approximately 1.49 standard deviations. If I was lower, if I was like 3 standard deviations below it, then I would have had a -3, and that would have been something very abnormal. Okay, so some of the properties of z-scores are unitless. That's something that to note. If the data value is below the mean, the z-score is negative. If the data value is above the mean, then the z-score is positive. If the data value is equal to the mean, the z-score is 0, okay? Now, this is the last question. I want you to go ahead and do this on your own. We will go over this question in the beginning of class. So try this one out and see what you can do with this problem, okay?